Hi again, dear student. For the next section 3.2, here we are going to talk about the transformation with functions. Means that we will play with we will manipulate with the graph, about this sketching the graph. For example, if I have y is equal to x squared and I want to manipulate plus c or minus c outside this graph, means that I'm talking right now about the page 65 in your lecture note. So when I say horizontal shifting, means that going upward and downward, we are manipulating with the graph going to upward or downward. For example, if I have y is equal to x squared plus 5, we are going to here's your standard, y is equal to x squared, and then we are going to adding the 5 we are going to upward. So we say vertical shifting and going to upward, y is equal to x squared plus 5. It will be like that, 1 2 3 4 5, and here we are going to sketch the graph. This is the graph of x squared minus 5. When we say y is equal to x squared minus 2, means that we have the standard form and going to down to 1 2 to here to start from the minus 2. So minus 1 minus 2, and I'm going to the start or sketching my graph from the minus 2. So the point here will be 0 and 5. Here will be the 0 and 0 because we are starting from the original one. This is the yx squared. For here we will start with the 0 and minus 2. It will be the minimum point for our graph. So when I say starting point, means that the minimum point, and the important things here, the shape. So how to going to up and to going to down from the vertical shifting. So when I say f of x plus minus c, means that if we add a constant number outside the graph, here's the outside the graph, because the later you can check the page 66 in your lecture note, you can see f of x minus plus c inside the graph. So this one the outside and this one the inside. Now I'm going to talk about a horizontal shift of the graph. Means that the page 66, for example, if I have f of x is equal to x squared, now horizontal shift will be like that. F of y is equal to x minus 2 or 3 square. You can see we have the square root, we have the square, so it means that our original shape should be like that. But because I have a minus plus inside here, because we have a minus, means that going to the right side by the 3 units, 1 2 3. Careful, the minus should go to the positive of x and the plus should be go to the negative x. I mean, when I say go, should be the shift to the right, shift to the left. So when I say minus, shift to the left, so I have what? I have the same shape, but we shifted by 3. Another example, y is equal to x minus plus 1 square, means that this is the original one, we have this shape, but because I have minus inside the function, is not like that. It's different from that, this one the vertical shift, this one the horizontal shift. So it should be the shift from the left side by 1 unit. So I'm going to minus 1 and I'll have the same shape. And after this one, please check the example 2 in the page 66. You can find a more example. And when we have the combine combine between vertical shift, vertical and horizontal shift, means that going to up and right or another way that we want. For example, we have y is equal to square root x minus 3 plus 4. Now, how to sketch this one? The first of all, you should recognize the standard shape that you have. We have what? We have square root. So here's the square root. Y is equal to the square root of x. Now, try to start from the inside. So the inside I have what? I have minus 3. And you know the inside means that horizontal. And you know the plus is going to the left, the minus going to the right. So next step, I have what? 1, 2, 3. So I have that shape. So this is the graph of y is equal to x minus 3. And last step is going to what is working on what? Is working on the is going to work on the vertical shift outside the graph. So we have what? We have plus 4. Now I am going to what? Here's 1, 2, 3. Here's my starting point. I'm going to up, you know, plus minus, plus 4 minus 4. So 1, 2, 3, 4. I have this point. This point is what? 3 and 4. Sorry, 3 on x, 4 on y. So 3 points over x, 1, 2, 3, and 4 points over y, 1, 2, 3, 4. So I have the shapes something like that. So in general, it would be like that, the same shape, the curve like an x square, but over 3 here and 4 there. That's all. Y is equal to square root of x minus 3 plus 4. I hope you get the idea here, and it's very important because really in the exam you will combine together, not just a simple doing plus or minus. Now another things in the page 67. The page 67 in your lecture note, you are going to reflecting the graph. How we will do it? How we will reflecting the graph? You will reflect it by minus. How? Maybe the reflection be inside the graph, outside the graph, or the reflection be inside the graph. So by reflecting means that we have minus. We will do it together. So if the reflection y is equal to minus f of x, means that the reflecting over x-axis, means that x-axis is our mirror. When the negative or the reflective is inside the function, means that y-axis is our mirror, is our reflection axis. How? For example, we have y is equal to square root of x. You know, here's y is equal to square root of x. Okay, now I am going to change to another one. How? By reflecting. For example, I say y is equal to outside here. So means that our reflecting is about what? Is about x-axis. So this is the original. So reflecting, or the mirror, if the mirror is the x-axis, so the graph should be like that. So this is the graph of y minus x, square root of x. Now for the third example, I'll have like that, minus x, square root of minus x. So if this is my original one, and because it's inside, we say that y-axis will be our mirror. Here's x-axis, here's y-axis. Will be our mirror. So our mirror will be like that, you know, the mirror will sweep between right and left. So we have something like that. So this is the graph of y is equal to square root of minus x. That's all you need to distinguish between the reflection or the reflector factor is outside the graph or the inside. If it's outside, do not forget about the mirror. It should be the x-axis. Otherwise, it should be the y-axis. Now I have an exercise for you to do it to yourself. If I have something like that, now I combined between both of them. Can you see how you do it? Okay, let me deal with this one, not be the exercise. This is my original one, and you can say because I have minus, so it will be here, and reflecting this one will go into there. So my graph, this is my important part of the graph. Y is equal to minus x. Can you do it again? Here's the original, and because I wanna minus x as example 3, as in the third example we did it, so it's going to here. Now reflecting this one, because I will reflect it outside means that what? Means that x-axis. So I'm going to the third quadrant. Can you see? We will go, if you have just this one, I was going to the fourth quadrant. In the here, I was in the second quadrant. Here, we should go to the second and then reflecting to the third quadrant. That's the manipulating or transforming the graph in the mathematics on the axis. About the vertical stretching and shrinking, it's okay. If it's the number is in your page 67 is just changing the shape. If you are going to the page number 68, you can see the difference between the example 5, A and B. You can find the purpose of the stretching and shrinking. When we see the stretching means that we are multiplying vertical stretching. When you multiply by the 3, for example, you have y is equal to x square. You know, this is the shape. If I say y is equal to 3x square, this one means that the graph is stretching to y-axis. So that's why we recalled as a stretching, vertical stretching. It's going to near the y-axis. But in the exam, it's not important because really we are dealing with the shape here, not the more specific points here. Also, if you multiply it by y is equal to 1 over 3x squared, we multiplied by the smaller than 1. So here's a c greater than 1. Here's c is between 1 and half. Means that if you multiply the function by the rational number between 0 and 1, you will see the expanding here or shrinking to the vertical here, like that. So this is the graph of 1 over 3x squared, the same shape but a little bit shrink it, and this one stretch it. That's all that you have here in the example 5, but it's not important. The important thing is to know about the shape of this one and that one. They are the same shape like a U, and how the important things are reflecting and collecting together. As I told you in the exam, because we need more idea, we should combine more idea together, is what is going to example 6 in the page 67 in your lecture note again, because, sorry, 68 in your lecture note, because it combines all the ideas here together. For example, you have what? Y equal to, or y is equal to f of x. The graph is the difference between them. Y is equal to what? Y is equal to 1 minus 2x minus 3 square. Now you can deal with this one from the left to right, or right to left. It depends how to you want. For example, I'm starting with the original one. We have y is equal to x square. Okay, now the original shape here is x square, like u. Now I have what? Inside I have x square is the shape, the first step. For the second step, I have inside, I have what? I have minus 3, and I know minus 3 is like that. For the third step, I have what? I have multiplied by 2. As I told you, this means that the stretching, so it's okay. 1, 2, 3. We don't deal with this one as an important part. So forget about the stretching. Just write y is equal to 2x minus 3 square. For the third, I have what? I have negative. Negative means that what? Because the function and negative means that outside the function means that what? Our x-axis is the mirror. If I have triangle here, I will find the triangle like that here over the x-axis, and upper and over and under. So I have what? And the fourth step, I have the reflection. So here's the 3. I'll have something like that. So this is the image for what? X minus 3 square. And finally, in the fifth one, I have what? I have 1. 1 means that what? You can write down like that. Look. Minus 2 x minus 3 square plus 1. Am I right? Yes, because this plus 1 can change it. So, okay. So if I have 1, means that plus 1. Plus 1 means that if I have plus or minus outside the function, means that what? Means plus minus c, I mean. If I have f of x plus minus c, not the reflection. So means that shifting vertical, forward or downward, upward or downward. So upward or downward, because I have a plus 1, means that going to upward. So I have what? I have 1, 2, 3, reflect, and plus 1, like that. So it's going to something like that. Now I have this is the graph of 1 minus 2 x minus 3 square. That's it. So we combine all together. In the fifth step we finished. Why? First of all, you have the original x squared. The second we have minus 3. So I'm going to minus 3 here from the to the left right side. And because I have the 2 means that the vertical shrinking or stretching. So forget about this one. And because I have a minus here, so I'm going to reflecting the graph toward of the x-axis. Don't forget that. And because I have a plus 1 here, so I'm going to upward, so shifting to upward on the vertical line. That's all that you need here in the 2.3. One more things in the page 9, it's important also in the exam. Sometimes we have the functions, type of the functions in the page 69 in your lecture note. Type of the function according to what? According to odd and even. Maybe our function be odd, maybe be an even function, or maybe neither. Okay, now for being odd function, we say if f of x, for both of them, if f of x, we give minus to inside. Now I have a f of x, the original. If I put, forget about this one, if I put minus in front of each x and the result is equal maybe to the same function that we have, or maybe equal to the minus f of x, means that we can factor minus 1 here. Factor, you know, Haber's command. We took the factor minus 1 here, or maybe neither. So in this case, we say it's odd, it's even, sorry. In that case, we say an odd function. That's when we say neither odd nor function. So it's better to see it by the example. If I have f of x equal to x to the power 5 plus x. Now I am going to give f of minus x, as I told you. So when I say f minus x, means that to the power 5 plus x. So in front of each x, give minus. Now you know, because the order is, the power is odd, so the minus will come out. It's okay. And also we have here minus. Now this one is equal to our function, to the original? No, of course. Our original with the equation star. This one is equal to the equation star? No. Why? Because this is a plus, this is a plus, and that one, they are both negative, no, minus. So I'm asking another question. It's not, so it's not even. Is the equation star is equal to the negative f of x? I don't know. I should take the minus as a factor. Let me see. X to the power 5, and you know, if the factor should be plus, because we took out the minus, negative by positive, you get a negative, negative by positive, you get negative. So I got this one. This one is equal to minus or f of function. Let me see. This is my function. This is minus. Yes. Is equal to what? Is equal to negative f of x. So it means that the function f of x is an odd function. I'm going to the other example in your lecture note. G of x is equal to 1 minus x to the power 4. I'm asking about the negative. The function is odd or even. So g of x, I don't know. I should give the minus. So I have 1 minus what? Negative x. So as you know, this one, because the order or the power of the x is equal to 4, and so even order, so I get what? I get just x. So x to the power 4, the negative will go. So I'm asking my question, this example, this equation, that be the original, be the star. This equation, that be the hash. This equation is equal to star. Look, this one is equal to that one. Yes. If it's yes, so means that what? Means that my function is what? So our function is what? G of x is an even function. Okay. Number 3, example 3. H of x is equal to 2x minus x squared. Now I should This is my equation star, I know, my function. Now I should give minus to each x, so I get what? Look, in front of each x should be minus x. So because this one is negative, so I get negative x square, and because I have a negative, and because I have a square here, so I get just x square. No, the square will damage the negative here or change it to the positive. So I am asking the question again. This equation equal to that equation or not? Let me see. This is my equation. That's my original. So after adding the negative, I got this hash, a double star. So equation hash is equation is equal to that equation star. I don't know. Let me see. I'll see. Negative 2 negative x squared is not equal to negative 2. No, I have no negative 2 here. Here's negative, here's negative. Okay, but how about here? No, it's not. How about equation hash is equal to negative star? This one is not, means it's not even. Okay, now I'm checking the function is odd or not. I don't know. Let me take a negative here. I get what? Negative 2x plus x squared. Okay, now this one is equal to that one. Is that equation is equal to my negative here? I don't know. Let me check. I have positive here, negative here, so it means that is not equal. Also is not odd function. So means that h of x is neither odd nor even. That's all. So please try to solve the exercise 75, 77, 79, and you kind of control this section. That's all about the page 10. That's all about your lecture about the 2.3. Next we are going to 2.4.